We're going to delve into some more of some of the things we learned on Tuesday. It's going to give us a chance to look at some of this code again that we were working with. We're going to talk more about the concepts behind it. Hopefully it's going to start to make more sense now that you've spent a little time with it. So one of the biggest benefits of using Express is routing. Okay, the ability to have separate request handlers for each URL and method combination. Remember that this wasn't possible when we were creating that raw server just with native HTTP. Remember when we did that, since that only allowed for a single request handler for the entire app. It didn't matter which path you were going to, it would always use that same request handler. But now that we're using Express, we have the ability to have a different function for every single endpoint, for every path, right? No matter how many endpoints we actually have in our system, we can have separate request handlers for each and every one of them. And that gives us a lot more organization in our code. It helps us keep a separation of concerns. You know, we can have different code for different endpoints that do different things, obviously. It just helps us organize our code a lot better. So we're going to dive deeper into that tonight, and we're going to discuss how we can piece together several different routers into a single application so we can kind of split things up a little bit. We're going to learn some different ways to get data from the request. So we've learned so far how to get data from the request body, right? And we've learned how to get data from URL parameters. Remember when we define a chunk with a colon and then some name? There's actually a third way called query strings, which we'll talk about a little further tonight. And then we're just going to talk about some higher level concepts about how to organize and name our APIs, how to organize everything. Sound good? So I think you'll find as you progress in your careers as a developer, one of the hardest aspects of development is organization and naming things. Okay, it's actually really difficult to write simple, straightforward code that's bug-free, organized, readable, has good names, and works well. Right? That's like, it sounds easy to keep things simple, but it's actually really difficult. So something that helps us do that is following conventions. Who knows what a convention is? Yeah, essentially it is a recommendation, right? It's a guideline, best practices, agreed upon standards. It's a way that things are usually done. They're not strict rules or strict requirements. It's just a standard that most people adhere to, okay, a convention. So conventions in coding are just recommendations as to how we name things, recommendations as to how we organize files, just how we build programs in the best way. It helps us with this problem of learning how to name things, learning how to organize things. It makes it so we don't have to think about it as much. So this is where the REST architecture helps us out with our API. So REST, it stands for Representational State Transfer. And it's just a convention or an agreed upon recommendation for naming and organizing our API endpoints. All right, so the REST convention, all it says that we should have a single resource per endpoint. A resource being some piece of data that we're saving, like a user or a product or an order or a student or some kind of resource, right? We should have a single resource per endpoint. An endpoint should never deal with more than one resource. So take a look at this site, and we're not going to go through it, but read through it when you get some time. This is a really good resource, bookmark it. and read through it if you want some more in-depth explanations as to how the REST architecture works and some of the things behind it. But some basic things to keep in mind when we're designing a RESTful API. The first one we just mentioned is we think of everything as a resource. So a user or a blog or posts or comments, things like that, right? Any piece of data that's being represented in our database or somewhere else in our app is referred to as a resource, okay? Now, each one of these resources should have its own unique URL. For example, the users resource in our previous project was accessible with the /users URL, right? Or a specific user, a single user, is accessible with the URL /users/some ID, right? That would be that resource's URL. Something else to keep in mind is URLs, they should utilize HTTP methods for each operation, rather than specifying the operation as part of the path. Right? For example, if we were designing an API that was not RESTful, you might define an endpoint like list users, /list users. Right? But if we were designing a RESTful API, it would be better to define that endpoint as a get method for /users, right? So the former would be considered not RESTful. The latter would be considered RESTful. When we have an API that conforms to the REST convention, the REST architecture, we refer to it as a RESTful API. So let's take a look at some of these other endpoints that we've been dealing with. So we have /list users, right? That's not RESTful. If we were to make that RESTful, it would be a GET request for /users. What would be the RESTful version of get user by ID? If we had an endpoint for getting a specific user by their ID, non-RESTful way to do it would be to define it as just /get user by ID. What would be the RESTful way to define that endpoint? Good. We would do get method /users/ID. I like how the colon ID does the emoji. What about creating user? If we had a non-RESTful API and we had an endpoint for creating user that was just /create user, what would the RESTful version of that be? Good. It would be post /users, right? A post method at the /users endpoint. What about updating a user? If we wanted to update a specific user by their ID, what would the RESTful version of that be? It wouldn't be just /user because we have to specify which user we're updating, right? So in this case, it would be put or patch /users/ID because we're updating a specific user. Good. What about deleting a user? What's the RESTful version of that? Good, you got it. Delete /users/ID. You guys got it. This is the RESTful way of organizing our endpoints. This is the convention that was defined that helps us organize and name things. Now remember, we can have several different operations available on a single URL just by differentiating between the methods, right? So we can use /users several times in our API as long as the method is different. right? You can have a get slash users, you can have a post slash users, you can have a put slash users, delete slash users. As long as the method is different, you can define endpoints with the same path. Okay, that's part of this REST architecture. That's what helps us think of every endpoint as a resource, right? You have a user resource, and then you have all of these CRUD endpoints that deal with that user resource. You can create that user, delete that user, list those users, so on and so forth. Let's take this one step further. What if we had a sub resource for users? Let's say we have a sub resource of friends. Okay, let's say a user has many different friends in our API. Now, what would the endpoint be for listing all of a user's friends? What do you think? Instead of slash list user friends, what would be the restful way of doing that? Good. Since friends is now a sub resource of users, we just tack it on to the end of the user's URL. So it would be get slash users slash ID slash friends. And that would get the friends list of that specific user. And since this is following the convention of REST, that friend resource still has its own unique URL, right? That URL doesn't deal with any other resource. What about getting a specific friend of a user? What would the endpoint be for this one? Instead of get user friend by ID, good, we would just tack on another friend ID to the end of that URL. Right? Only in this case, since we're now dealing with two IDs in the URL, we have to give them different names. So the RESTful version of that would be get slash users slash user ID slash friends slash friend ID. What about creating a new friend for a user? What would the RESTful API endpoint be for creating a new friend for a specific user? Good. We would do a post request to slash users slash ID, since it's for a specific user, slash friends. What if we wanted to get a list of all of the friends in our database, not user specific, but just all of the friends in general? What would the endpoint be for that? Good. Yeah, in that case, it would just be get slash friends, right? You can have multiple endpoints for your resource depending on where it sits in that hierarchy, right? Whether you're just getting everything from the database or if you're getting everything that's specific to a user, if it's a sub resource. And if we're following this REST convention, we can piece together these endpoints really, really easily. And it's easy to understand when you're using this API, right? When you call this endpoint, you know for sure that you're getting a list of that user's friends, not just all of the friends in the database, right? They're going to be specific to that user. And that's REST. Okay, that's the gist of it. Don't overcomplicate that concept in your head. Really, if you just keep those conventions in mind when building out an API and you think of every endpoint as managing a single resource and you utilize HTTP methods along with the paths, then your API is just going to naturally become RESTful. Okay, if you find yourself starting to define endpoints like this, then you know you're doing something wrong, right? You might have to relook at it and try and figure out how you could make it more RESTful. But you don't have to think about this too much. Don't overcomplicate it too much. It just kind of comes naturally as you start to get these conventions down. So that's REST. There's a lot more that goes into it, which you can read about here on the restfulapi.net site. A lot of really interesting things regarding it, talking about state and cache and things like that. But that's the gist of it. All right. Any questions about that? Please keep your Slido questions on topic. That'd be great. All right, so question in Slido, will doing get/friends, will that bring in all the user's friends or all the friends in that API without counting the user? Yep, so if we wanted to get all the friends for a specific user, right, then we would define an endpoint like this as a sub-resource under user, right? Now, in the case that you wanted to get all of the friends in your entire database, maybe not specific to a user, then you might define another endpoint that's just get/friends, right? That wouldn't be a sub-resource of users. What if you use React Router? Would it get confused? No, this doesn't really have much to do with React Router. So React Router, you're defining routes on your front end. And then when you're defining routes on your back end like this, then you would just be calling these endpoints with Axios or some kind of HTTP library. This doesn't really have anything to do with React Router, okay? If you're on a different endpoint on your front end, let's say you're on like /settings or /account or something, you can call any API endpoint from there. It doesn't have to match the route that you're currently in. Okay, they're completely separate, if that's where you were getting held up. All right, let's open up the project for tonight. If you just open up the code. Now that we understand REST a little bit, let's take a look at our code and see if it's following our convention. So open up index.js. And you'll see that we have a user resource and 5 different CRUD endpoints to manage that resource. So we have get/users for listing all of the users in the database. We have get/user/ID, which helps us get a single user by their ID. We have post users for creating a user. We have put users/ID for updating a specific user. And then we have delete/users/ID for deleting a specific user. So listing, getting by ID, creating, updating, deleting. We have all of the CRUD operations available on this resource. So this is currently following the REST architecture. This API is considered RESTful. Go ahead and get it up and running. If you go into your terminal and just type node index.js, start that server up. And then open up Insomnia and let's make a couple test requests just to make sure it's all up and running. Good to go. So I'm going to make a call to the welcome route, which is just the /. Our URL is going to be http://localhost, and we're running on port 4000 tonight. So port 4000 and then just the /. Make sure you can see the welcome to our API. Let's also make another request to /users. Make sure we're getting a list of our users. So I'm just going to duplicate that. I'm going to call it get users. And then I'm going to update this endpoint to /users. And you should see Jane Doe, John Doe, and Jack Doe. Let's try one more just to make sure we can get a specific user by their ID. So I'm going to duplicate that and call it get user by ID. And then just try to make a request to /users/1 and make sure we can get Jane Doe. Cool. Yeah, and make sure you npm install Julio. It's always a good thing. All right, now before we move on, let's set up a few helpful npm scripts. If you've never done this before, this is going to be good practice. Hopefully you've done this before, but if not, let's just walk through it really quick. So right now we've just been calling, to start our server, we've just been calling node index.js. Right, but if you remember from previous projects, you might have been able to call something like npm start to start your server instead of calling that index file directly. This is not going to work in our project right now if we just called npm start because we haven't set up that script yet. It's actually really simple to do. We're just going to go into the package.json. This is where we define our npm scripts. We're going to go to the scripts object. It's going to be empty currently. And we're going to add a new key. We're going to add a key for start. And then whatever we put in that value is the command that gets run when we run npm start. So the command would just be node index.js. So it's kind of like a proxy, a shortcut, right? Now if we have some really long start script, we don't have to retype it every single time. We can just type npm start and it'll run that pre-written script for us. So now we would be able to go into our terminal and instead of typing node index.js, we can say npm start. You can put whatever script you want in here. You can customize this however far you want. You can put 10 different custom scripts in here that deploy or lint or do any type of thing. They're just pre-written scripts behind aliases, essentially. Do take note that the only scripts you can run without the actual word run is start and test. You can define a start script and a test script, and you can run them with just npm start or npm test. If you add any other custom scripts, you have to call it with npm run and then whatever your script name is. Let me show you that. Let's add a custom script. So another annoying thing is having to manually restart the server every time we make a change to the code. You might have installed nodemon in the previous project to get around this. Let me just show you how to do that really quick before we move on. There's this library called nodemon, which all it does, it just keeps an eye on our JavaScript files. And if anything ever changes, if any files ever change, if we update it and then save it, it's going to restart our node server automatically. So let's go ahead and install nodemon by just saying npm install nodemon. And we're going to save this as a dev dependency by just saying -- save dev. And that puts it in this dev dependencies list rather than the dependencies list. And that's because nodemon is a dependency that's only used on our local machines. Okay, if we were to deploy this API to, say, a web server somewhere, nodemon wouldn't actually ever need to be used. So since it's a local development dependency, we put it as a dev dependency. We install it, and then we can come into our script, and let's add a new custom script called watch. Let me give you a few seconds to catch up there. So I ran npm install nodemon save dev, and then we're adding another script called watch. And don't forget the comma after start, since this is just a JavaScript object. Now inside of our watch script, instead of calling node index.js, we can now call nodemon index.js. And once we have that script in there, we can now call npm run watch. And when we run watch, nodemon is now going to watch all of our JavaScript files, and if anything ever changes, it'll restart our server automatically. So that's good to know. Just know that you can specify these custom npm scripts with custom commands, whatever you find yourself repeatedly typing, put it in an npm script, and then you don't have to type it over and over and over again. And on top of that, your npm scripts can access your node modules dependencies. So it can access nodemon, for example. And it can access other CLI applications that are installed through node modules, which we will see in later lectures. Okay, so now watch carefully. If I were to come in here, let me make this smaller. If I were to come in here and change something in index, watch what happens in my terminal. If I just like change the welcome message, then it detects that change, restarting due to changes, and then it restarts the server. Cool. All right, so now that that's out of the way, let's go ahead and move on. So question in Slido, in the start script in package.json, can you use nodemon and use npm start in the terminal to utilize nodemon? So they're asking, can you just switch up the scripts, right? Can you just put nodemon directly in start? Yeah, absolutely you can. But keep in mind that there are times when you're going to just want to run node directly without nodemon. If it's running on a web server, for example, and you're not actively developing it. All right, so you want to make sure you still have a script that can run just the index file without nodemon, and a script that can run it with nodemon. So you can name the scripts whatever you want. It doesn't have to be start, it doesn't have to be watch. Just make sure they're there. Good question. Why would we save as a dev dependency? What does this mean? What does that provide? So when we save it as a dev dependency, it's good to just keep your dev dependencies and your production dependencies separate. Because again, if we were to install this application on a web server and we went into npm install the dependencies, we might not want to install all of the development dependencies because they're not needed in that environment, right? You don't need nodemon unless you're actively developing your application. And you're not actively developing it if it's on a web server, right? Running on the internet. So in those cases, you can just run npm install -- production, and that only installs these dependencies, and it saves you a little bit of time. All right, let's talk more about these endpoints. We don't have a lot of endpoints yet. We only have 6, including the welcome route, so it's not a ton. But in a real application, you might have hundreds or even thousands of resources, right? And for each resource, you have multiple CRUD endpoints for each one, right? Somewhere between 4 and 5 endpoints for each resource. So if you have thousands of resources, your endpoints are going to add up really, really, really quickly. And you can't just shove all of them all into this single index file if you have thousands of them, because this index file would get gigantic and it would be really hard to maintain. So the obvious solution would just be to start splitting the code up into separate files, right? So let's do that. Let's start off by just splitting out some of these, well, all of these user resource endpoints into their own file. So we're going to create a new router file just under users in the users folder. Let's create a file called users/router.js. And then let's cut out all of these users routes. So every route except for the welcome endpoint, and put them into that new file that we just created. So everything between server.get/ and server.listen. And just paste it into that new file. Okay, so we extracted our users endpoints. We put them in a new file. Tasha, it sounds like you cloned the wrong repo. Make sure you clone the repo that was in the message I posted earlier. So we've extracted all of our user endpoints into users router out of index, but it's not going to work quite yet. If you were to run this right now, it's just not going to do anything. We still need to require this users router back into index, right? We still need to tell our application about these routes somehow. So how do we do that exactly? What are the steps we need to do in order to import this data into our index file? Yep, the first thing we need to do is export something from this file, because remember, you can't require anything. You can't import something into another file unless it's exported. So what do we export here? We don't really have anything to export quite yet. As it stands, this server variable is undefined. Because if you remember before in index, that server was created by calling express. Right, but that's no longer defined in this file, so we need to define that somehow. So in order to split things up like this, express, it allows us to create what's called standalone routers, which are essentially just little mini express applications which we can merge into the main application. So to create a standalone router, all we have to do is import express. So we'll say const express equals require express. And then we're just going to say const router equals express dot router. That just creates a standalone kind of mini express application, express router. So we now have something to export. Oh, and while you're at it, make sure you rename. So now we're going to rename all of these instances of server dot, rename those to router dot. So quick tip, I use this one a lot. If you're in VS Code or Sublime, you can highlight a word and then press Command D, or Control D if you're on Windows, and that will select all of the instances of that word and just keep pressing it over and over until it reaches the end of the file. And then you can edit them all at once. So you're going to change the word server, change that to router, since we want these endpoints to be created on our sub application and not the main server. Okay, so we imported Express, we created a new router, and then we renamed server dot to router dot. And then the last step is to just export that router. So I'm going to come all the way to the bottom and I'm going to say module.exports equals router. So now we have this standalone router. We now have the ability to pull endpoints out of the main application, run them kind of in their own mini application, and then we export it so we can then require it back onto the main application later on. So this method of importing and exporting, by the way, the syntax of using module.exports and require, this is known as CommonJS. CommonJS. And it's really similar to the modules method you were using in React with import and export default and export function, things like that. It's just an older way of doing it since Node doesn't fully support modules yet. Okay. So essentially whatever variable or function we require or we import with require, we have to export with module.exports. Hopefully that makes sense. You'll get more familiar with that as you use it over and over, as you start to split your code out into separate files. Just know that whatever we export with module.exports, we later on import with require. All right, so now that we created the standalone router, we exported it. Let's go ahead and import it back into index. So we're just going to go to the top of index and we're going to say const users router equals require dot slash users router. And that users router variable, that is now the same as this router variable that got exported, that standalone router. Now the last step is to just attach that router to the main application, to the main Express application. To do that, we use the same syntax we used with express.json. We're going to talk about this syntax later on, more in depth next week. But for now, in order to attach that router, we just say server.use, and we pass the users router. Sure, Amy. All right, I realized that was tedious. A lot of cutting and pasting, but that's how we extract routes into their own files with Express. Alexander, user's router is imported right into index. Here, let me see. I don't have a ton of real estate here, but it might be better to do columns. How's that? If you go ahead and save this and try starting it, well, your server should automatically restart if you're running nodemon. And try calling an endpoint. I'm just going to try calling get user by ID. And we get a 500 internal server error. Get this reference error in the response, and we also get it logged out to the console. We jump over to the console. Who knows why that's happening? Oh, Simone got it. So users is not defined. So essentially we're trying to use a users variable somewhere where it doesn't exist, where it's undefined. So take a look at this stack trace. Don't be afraid to read into the stack traces of errors. I know they can be really intimidating, but when you get errors, just look at it as an opportunity to delve into the stack trace and figure out where exactly your error is. It tells you a lot. So if you actually read the stack trace, you'll see users is not defined, and then it tells us exactly what file and line number the error is occurring at. So we'll see that the error is occurring in users router, line 21, character 2. Okay, keep that in mind. Don't be afraid to dive into the stack traces and the error messages. They'll always, most of the time, they'll tell you exactly what went wrong and where. So if we jump over into the users router, line 21, this is where the error is occurring. So the users is undefined. And that's because it was imported into index, that users model, when we were using the routes in there. And when we copy them over, we didn't import that users model again. So we just have to make that variable. We have to define that variable by just importing the users model. So if you want to just cut that line 2 out of index, put it on the line 2 of users router, and adjust the path. Since we're no longer one level up in that directory structure, we're now in the same directory as users model. You can adjust that import path to just / users model. Josh, make sure you do an npm install. All right, go ahead and save that. Once you make that change, try it again. So we restarted, try calling the endpoint again, and we are good to go. All right, any questions about what we just did or why? Yep, you will delete the user's model import and index because you no longer need it. It's no longer being used. So you can go ahead and just delete that line. All right, let's take a 5-minute break. I'll see when you come back. All right, come on back. How's everyone feeling so far? We just did a lot of typing. I realized that. Awesome. If you're feeling confused, if you're feeling overwhelmed, that's totally normal. Take some time to start to grasp some of these concepts and some of these conventions that we're talking about, some of this code that we're writing. So just be patient with yourself. You'll get it eventually, I promise. All right, let's take the next 5 minutes on your own. See if you can extract the welcome router or the welcome route. See if you can extract that into its own router in a completely separate file. All right, I'll give you about 5 minutes. Let me post that into Slack. So take about five minutes, see if you can extract that endpoint into its own welcome router. And when you get done, give me the heavy metal horns. FYI, if you've asked a Slido question, I'm answering several of these just right in Slido. So if you ask a question in there, keep an eye on it and you might see a reply. I'll give you a couple more minutes to finish this up. All right, go ahead and stop where you're at. And let's go through this together. So the first thing we're going to do is we're going to create a new router file. I'm just going to create a new folder called welcome. You can put the file wherever you want, just to follow the same structure that we currently have. I'm going to create a welcome folder. And then inside of the welcome folder, I'm going to create a welcome router. Welcome router.js. And then in here, I'm just going to import Express. I'm going to create a new router by saying const router equals express.router. Don't forget to uppercase the R on router. We're going to module.exports the router. And then you can go ahead and copy that or cut that route out of the index, put it into welcome router, right between the router and the export. Rename server to router, since we're attaching this endpoint to the router. And then we're going to import that file into index. I'm just going to do it right above users router. I'm going to say const welcome router equals require dot slash welcome dash router. And then last but not least, just attach it to the main application by saying server.use welcome router. All right, let's test it, make sure it works. Run npm watch again. Make the request with Insomnia. And we're good to go. All right. Now, occasionally, a resource is only going to make sense within the context of another resource. So like we talked about before, right? We're talking about friends of a user. In this case, the friends resource, it really only makes sense when it's under the user's resource, right? You can't really have friends without someone that has those friends, right? In this case. Some other examples is, say, like orders. You can't have orders, you can't have an orders resource without users. Or you can't have likes without posts. right? Or you can't have comments without posts, or you can't have posts without users, right? Sometimes a resource only makes sense within the context of another resource. So in our project tonight, we have another resource called posts. If you think of this app just kind of like a really simplified Twitter, we have user signups, and then each user can have small pieces of text, right? Posts. And in this case, the posts, they really only make sense within the context of a user. They don't just materialize out of thin air, right? They have to be created by a user as a sub-resource. So if you take a look at the model file, the user's model file, you'll see all the way down at the bottom, we have three functions for dealing with these posts. We can add a new post for a user by calling add user post. And that expects a user ID and the post data. We can get a specific post for a user by calling find user post by ID. That expects a user ID and a post ID. And then we can call find user posts for getting all of the posts for a user just by passing the user ID. So if we're following the REST architecture and we wanted to find an endpoint for listing all of the user's posts, how would we do that? What would the endpoint be? If we go into users router, go all the way down to the bottom, and we wanted to find a new endpoint for returning all the posts for a user, posts, they only make sense within the context of a user, how would we define that endpoint? Good, Vish. We're going to say get. So router.get. And the endpoint in this case is /users /user ID /posts. All right, it's not just /posts because we're not getting all of the posts in the database. We want to get posts that are specific to this user. So go ahead and create an endpoint for that. And then the function we're going to call, if you look back in the user model, is find user posts. And then we pass a user ID. So let's go ahead and call that function, find user posts, by going back into the users router, and we're just going to call users dot find user posts. And we're going to pass the request.params.id, that ID that's coming from the URL. Now it's important to note that all of these model functions, they return promises. If you remember promises, just async code, right? So we have to wait for these promises to resolve before we can actually use the stuff that comes back from them. So to wait for these promises to resolve, we just call .then. Give .then a callback. And then if any errors occur when this function is called, we can catch them in .catch. And give catch a callback. All right, let's do our dot then callback first. So dot then, it's going to return the result of this function, which should be a list of the posts, right? It should be a list of the user's posts. And it's going to give that to us as a parameter. So we can just call that parameter posts. And what should we do with it? What should we do with posts? You could console log it, Julio, if you want to check to make sure it's actually what you want. For the sake of time, let's just assume it is what we want. And Eric, we're not going to check if it exists because it's going to be a list, right? So that list could be empty. We don't necessarily have to check to make sure it exists in this case. So let's just return it to the client. Just send it back. At this point, our endpoint is done. Just send that list of posts back. Right, it's okay if that posts value. It's okay if that's an empty array, because what if the user hasn't posted anything yet? All right, then it's okay for that post array to be empty. So you don't necessarily have to check for that. What about our catch statement? If you remember from promise chains, our catch statement should give us an error as the parameter. And what should we do with that error? Just log it out. We're going to talk about error handling more in depth next week. So hang tight on that. For now, we're just going to log out the error, and then we're going to send back some kind of generic message with a status code of 500. We'll just say res.status500.json, and then just give it a message of could not get user posts. And the reason we do that in this case is because we're not exactly sure what that error is. That could be like a connectivity error or some internal error with the database or some weird thing going on. We don't know exactly what it's going to be. So in order to prevent ourselves from potentially leaking in sensitive information to the client, we just want to return a generic message and then log the error out so we as developers can see it. But we don't want to return those details to the client. Versus if it was like a 404, for example, then we know exactly what went wrong and we can send those details back. Guillermo is using .then.catch, the same as using try catch. Kind of, yeah. .then and .catch is just how we resolve and catch errors with promise chains. Using try catch is more generic. That just catches generic JavaScript errors. If you're using it with async await, then it can catch promise errors, but we will talk about that next week. All right, let's see if that worked. So we created a new endpoint for getting a list of posts for a user. We called find user posts, passed through the user ID from the parameters. If that function is successful, if it resolves, then we send the posts back. If there's an error, then we log the error and send back a generic 500 error. Give that a shot in Insomnia. So we're going to create a new endpoint. I'll just duplicate get user by ID, call it get user posts. And we're going to make a get request to /users/1/posts. And you should see a list of posts. You'll notice that this is not a list of all the posts in the database. This is a list of posts for Jane Doe. If we were to call this same endpoint, but with the user ID of 2, we're going to get a different set of posts. Right? These are the posts of John Doe. You see, John Doe has much more. So since posts is a sub-resource of users in this case, we're only seeing the posts for that specific user, which is what we want. Let's write an endpoint for getting a single post. So we're getting a list of posts. Let's do the same thing, but get a single post by its ID. What should the endpoint be? Good. Let's go ahead and make a GET request. And the endpoint is going to be /users/ID /posts/post ID. Can't be ID because we were already using ID. So let's name this chunk post ID. And just for clarity, let's name the first ID user ID, just so we know exactly which ID is which. What's the model function that we call for this? It's going to be find user post by ID. And it takes in a user ID and a post ID. So let's go ahead and call that. We're going to call users.find user post by ID. And we're going to pass the user ID first, which is request.params.user_ID, and the post ID second, request.params.post ID. Once again, this is going to return a promise. So we get our .then.catch. If you want to just copy that entire catch statement from the previous endpoint, you can do that. It's going to be basically the same, so you don't have to rewrite it all. So copy the catch from get user posts, paste it into here. And then just change the message to could not get user posts to could not get user post singular. Once again, we're not exactly sure what went wrong here, so we don't want to send the error back to the client. We just want to log it. All right, and then our .then callback, where we should, if everything went according to plan, we should get a post parameter. Now, what should we do with post in this case? Unlike our previous endpoint, there could be a scenario where post is undefined. Right? If someone tries to call this endpoint with a post ID that doesn't exist for that specific user, then post could be undefined here. But unlike our catch statement, this is an error that we know about, that we're kind of expecting at some point. So it's not an unknown error. It's kind of a known error. It's something that we want to account for, that we know is going to happen eventually. So let's just write an if statement. Good, Julio. Let's write an if statement. Just say if. You can either do if post is undefined, do something, or just if post is defined. If post is truthy, then just send it back. Otherwise, send back an error. You could just do a 404. Okay, maybe just say 404 post was not found for that user. Save it and give it a try. I'm going to duplicate the get user posts. We're going to call it get user post by ID. Hit create. And then just tack on an ID to the end of that endpoint. So we're going to try and get a post, say a post ID of 1 for the user ID of 1. And it should give you this nice misspelled Lord of the Rings quote. Try getting a post ID of 1, try getting that same post, but change the user ID to 2 and see what happens. Well, we now get a 404, which is exactly what we want because the post ID of 1 actually does exist, but it's not for it's not for user ID of 2. It's for user ID 1. So now if someone's trying to get that post, but for the wrong user, it's just going to assume that it doesn't exist because it doesn't exist for that user. Right? If we tried to get a post from user 2, maybe say like post 10, then it should return okay. If we try to get post 10 for user 1, you'll get a 404. So it's not mixing them up, right? It's keeping posts specific to a user, which is good. All right, take the next 5 minutes and write a post endpoint for creating a user post. See if you can figure out the RESTful endpoint, the path that it should be for creating a new post for a user. Call the specific model function and see if you can get it to work. Let me paste that into Slack. So write a post endpoint for a user post. It should contain a request body value for text. So when you call this in Insomnia, you're going to send a value of text in your request body. You should take that in your endpoint and use it to create that post. You're going to call the function users.addUserPost. And if you take a look at that function, addUserPost, you'll see it takes a user ID and an object, and that object is what should contain the text value. Okay, I'll give you about 5 minutes, and then we'll go through it together. I'll give you about 1 or 2 more minutes. If you get it done, give me the heavy metal horns. All right, looks like a couple are starting to trickle in. I'll give you a couple more minutes to finish this up. And then we'll take a break. All right, let's do this. Go ahead and stop where you're at. So creating a new resource is obviously going to be a post request. So we're going to say router.post. The endpoint is going to be /users/user ID/posts. Now, the first thing we do before we call the method in the model, if you took a look at the requirements, it says to make sure to check for missing values. So one thing we want to do before we do anything is check to make sure we have the value that we're expecting. In this case, we're expecting the request body to contain a value for text, right? To have the actual content of the post. So let's just check for that real quick. Just write in a statement. We'll say if that doesn't exist. So if request.body.text is falsy, then just return some kind of error. Return a 400. 400s are usually the most appropriate for missing data. So we can say res.status 400.json. And we'll just say message need a value for text, or whatever you want. Because we don't want to continue on. We don't want to try creating a post if we don't have the needed data, right? Now, what's the model function we call? We are going to call add user post, pass a user ID and the post data as an object. So let's say users.add user post. First parameter is the user ID, which is request.params.id. Second parameter should be the post data itself as an object. You could do one of two things here. You could just send through an object with a value of text set to request.body.text. You can do that and kind of specify individually each value that you want to send. Or if you just want to make your life super easy, just send through request.body. That's not the best practice to do that, but it's okay for now. All right, and then that function is going to return a promise just like all the others. So get your then and catch. Go ahead and just copy the catch function from the previous endpoint so you don't have to retype all that. Sure. Change the message to could not create user post. You could also just return some generic message, just say like something went wrong. Please try again later, something like that. Again, we'll talk about that next week and more in depth. In the .then, if that post was successfully created, then we're going to receive the post value as the parameter to our callback function. And then we can just send it back as .json post. What's one more thing we could add in here? One thing that I might be missing. How about the status code? Let's set the status code to 201, since this is a creation operation. We could also check to see if the user exists, Daryl. Yep, if you want to do that before you actually create it, make sure the user with that ID exists. We won't do that just for the sake of time, but yeah, you could do that. Michelle, can you specify multiple keys individually? Yep. Yep, if you wanted to do multiple keys, you could. This is just an object, so you could say, you know, some other value. Just do it that way as well. What's one other thing we might be missing? Is there anything in this endpoint that you can spot that might cause a problem at some point? Think through all the different scenarios of what could happen and follow through with the code line by line. What are we missing here? What happens if we're missing text? If someone calls this endpoint and it's missing text, it's going to send the response back. It's going to send a 400. But in this case, the JavaScript is going to keep running after that point. There's nothing telling the JavaScript to stop running after it sends that request. going to keep running, and it's going to come through, and it's still going to try and create the post. It's going to try and send another response, and it's going to cause problems. You'll get an error that says something like HTTP headers already sent, cannot set headers after they are sent to the client, something like that. And that's because it's trying to send us a response multiple times. So what we want to do when we already know we're sending back an error, we don't want to run any of this code afterwards, just return. Whenever you return from a function, it's going to stop that execution, and it's not going to run any of the lines that come after. So you can return it like that. If you wanted to make it even shorter, you can just return the response directly, and that works too. And that way, if this error gets sent back, it's not going to try and run this code. Cool. Let's test it real quick. So I'll just make a new request. Duplicate the last one we made. I'll call it create user post. This one is going to be a post request. Send it to users/1/posts. You can take off the post ID on the URL. Set a request body with JSON. And we're going to send a value of text. Set it to whatever you want. And go ahead and send it off. We should get a 201 created. It gives us the details of the new post, the ID that got assigned. And then if you go try and list the posts for user ID of 1, you should see it down at the bottom. And there it is. Cool. All right, let's take another 5-minute break. I realize we're almost done, but go ahead and step away for 5 minutes or catch up if you need to. I'll see you when you come back. All right, come on back. Wake up, Vish. That's hilarious. I love that his image is just him sleeping. One of my previous cohorts, someone fell asleep during lecture on their keyboard, and they were like entering all this nonsensical stuff into Slack. It was hilarious. Don't do that. You'll never hear the end of it. I can assure you. All right, how's everybody feeling? I know we have a lot to go through tonight. Hang in there. Yep, we have one more thing to cover tonight in the last 15 minutes. That's a worthy way to spend your break, Vish. Props to you. All right, let's switch gears just a little bit here in our last 15 minutes. We're going to talk a little bit more about this request data. So up until now, we've just been reading data from the request body using req.body, right? That's one way of getting data from the client, by getting it from the request body. We've also been getting data from the URL parameters with request.params, req.params. That's another way for a client to send data to an endpoint, right? To specify some kind of value. These are essentially the two ways we've been using for clients to pass information to our server. All right, but it turns out there's also a third way for a client to pass data to the server, which is called query strings. So just like request parameters and unlike the request body, query strings are going to be part of the URL. Now, I'm sure we've all seen these before. I'm sure you've all seen a query string. If you just go to your browser, go to Google, and just type in something to the Google search. Just type in Lambda School. And look at this URL that got generated. You'll notice it looks a little bit strange. It has a question mark in it. And then after the question mark, it has all these crazy looking values. It's got all these ampersands and equals signs. But if you look closely, all it is, it's just a bunch of key values, a bunch of key value pairs that are separated by these ampersands. All right, so I'm just going to copy this and let's just break it apart and take a look at it on multiple lines. So I paste that into here. So essentially with these query strings, everything after the question mark in the URL is considered the query strings. So if we just break this up, we've got /search, and then we've got a question mark. And then after the question mark, we have source equals HP. And then we have an ampersand. And then we have EI equals this long string. And we have an ampersand. And then we have Q equals lambda plus school, and then an ampersand. OQ equals lambda school, ampersand. We just have all these key values, right, that are separated by an ampersand. So you'll see that Google, when you go search for something on Google, it's using these query string parameters in the URL for a bunch of random metadata, right, including our search query. And this data, it gets passed to their web server, and that web server is able to parse it and extract these values and use them in the code somehow, right? Use them in the route handler function. So it's essentially just query strings are just a really easy way to pass a lot of generic metadata or a lot of generic info to an endpoint without making it part of the URL path, right? Without having to define URL parameters for each and every one of these values. Right? Imagine if Google used URL parameters instead of query strings for this endpoint. Well, then what would it be like when they actually defined that endpoint in their code? It'd have to be something crazy. Like it'd have to be like /search. I'd have to define it like router.get /search /source /bi/q /oq /gslcp /sclient /bd /uict. That would be an insane URL. No one's going to want to define that, maintain it. That would be a nightmare. So instead, they use these query strings, right? So everything after the question mark is what's considered the query string of the URL. And you can have as many of them as you want in your URL, as long as they're separated by ampersands. And another key point with these query strings, unlike URL parameters, if you were to call this URL and you misplaced a couple of them, like let's say you accidentally put the value for EI first and then source after EI, then it's going to get them confused, right? Your app is going to get them confused. Versus query strings, the order actually doesn't matter. As long as you have the key matched with the correct value, it doesn't matter where it lands in that query string, as long as it's there somewhere, right? So you could make some of these values optional or all of them optional. You can put them in whatever order you want. It's just a really, really flexible way to pass some additional information from the client to the server. All right, they're a better solution when we're dealing with metadata. Now, when I say metadata, that just means a set of generic values that are not specific to one resource. Right, so they might be values that are accepted and used on many different endpoints rather than just one endpoint. What's a generic metadata value that you can think of that might be useful in some of our endpoints? Is there anything you can think of? Description, okay. What else? What maybe for like our users endpoint specifically? Users endpoint and maybe some of these other listing endpoints. What would be something that's useful for those? What if you wanted to change the order that they get returned in? Right now, they're just ordered by ID, right? Incrementally, ID 1 comes first, ID 2, ID 3. What if you wanted to list these in a different order? Maybe you wanted to sort them alphabetically by the name, right? That might be something that you would specify on many different endpoints. You could specify it on this endpoint. You could specify it on the get user posts endpoint. Let's implement that, a sorting order. Since our model function is actually already set up to accept that, we just have to pull the value out of a query string. So I'm going to jump back into the user's router. And let's just go all the way to the top. Let's go to the get users route. And before we call users.find, let's just console log req.query and save it. What Express does, Express will automatically parse any query strings that exist in the URL, and it gives it to us under that req.query. It parses it as an object and gives us the values. So let's just log that out and see what's in there. So if I call get users after I start the server, obviously. Oh, looks like we have an error. A floating F on line 174. I must have typed that accidentally at some point. Oh, there we go. Get rid of that. All right, now it started. Let's try calling get users. And we get the users as expected. Let's take a look at the console, see what it logged. And you'll see that it just logged an empty object because we don't have any query strings yet. We're not defining any query strings on this endpoint. But if we go back to Insomnia and try calling users, put a question mark, and then say sort by equals name, and then hit send. So we specified a query string just by adding a question mark and then a key equals value. Now, if you look at the console, you'll see it logged out an object and it actually parsed that value out into an object, and we can now call req.query.sortBy, and it gives us the value of name. So we now have the ability to take in these extra values from the endpoint without having to bring them in through the request body or the URL parameters. If we look at the user's model, if we look at that user's find function in the model, you'll see that it takes an object as the only parameter, and that object can specify some different values. You can specify a page, offset, a limit, sort by, sort direction. Let's just send through that sort by value from our query into this find function, and it should change that sorting order of the results. So when we call users.find, I'm just going to send req.query. Or once again, you could specify individual values by saying users.find and send through sort by request.query.sort by. That would also work. I'm going to take out that console log. All right, now watch what this did. If we go back to Insomnia, and I'm going to take that query string out, I'm just going to cut it out. I'm going to call the endpoint as normal without any query string. And once again, we get 3 users ordered by the ID, user 1, user 2, user 3. But now if we add that query string of sort by, and we set the sort by value to name, and we send it, look at our results. It actually parsed that value out of the URL. It sent that value to the model function, and the model function changed the results based on that value. It's now sorted based on the name and not the ID. Right? So now we have Jack Doe comes first, and then Jane Doe, and then John Doe. Okay, so we could do that same thing in get user posts. If we wanted to take sort by and send it to a model function and change the ordering, we could send maybe limits. If we wanted to limit this result to say 1 or 2 results instead of all of them, we could do that using a query string. If you even wanted to send your entire request body as query strings, you could do that too. That's been known. That's been known to be done quite often. So now we have this really flexible way to send values from the client to the server without having to use request bodies, without having to use URL parameters. Any questions about that? All right. I believe this is on the assignment. Yes. It is in the sprint challenge. So make sure you understand query strings, how they work. Don't overcomplicate them. Once again, just a way to send data from the client to the server. You're just adding these key values to the URL and you're pulling them into the endpoint and just using them however you need to, right? Maybe you're sending them to another function. Maybe you're using them to save something in a database or using them to log something out. However you need to use them. Oh, they're not on this. Okay, not on the assignment. Perfect. Well, that's no excuse to not learn them. All right, well, that's it for tonight. Let me give you a link to your project. I know we went over a lot of new stuff tonight, so give yourself time to soak it all up. Practice makes perfect, so just keep practicing, keep building things. We're gonna have plenty of time to go over all of this again. We're gonna have tons of practice with all these concepts. As we go through the block, we're gonna be reusing a lot of this stuff. So you'll see it again. We'll be able to talk about it again. You'll have chances to ask more questions. And yeah, that's it. Have fun with it. Good luck, and I'll see you all next week. Have a good night. Thanks.